All right, like I said, we are on page 393, and today we're going to talk about angles of polygons. And specifically today, we're going to be working with interior angles of polygons. And theorem 6.1 on page 393, polygon interior angles sum. The sum of the interior angles of a polygon is, we use the formula n minus 2 times 180. Where n is the number of sides. And a very simple example, the sum of the interior angles of a polygon is n minus 2 times 180, where n is the number of sides. If you think of a triangle has 3 sides, right? And you already know in your head what the sum of the angles of a triangle is. If we have a triangle with angle A, B, and C, what is the sum of angle A, angle B, and angle C? 180. We've been talking about it all year. So let's just take that as an example and apply it to this formula to see how it works. So this triangle has 3 sides. So if we were trying to find the sum is equal to, we take the n and we replace it with a 3, we subtract 2, and we multiply it by 180. So look what we get. What's 3 minus 2? 1 times 180 equals 180. So the sum of the angles of a triangle is 180 degrees. This 2 in the formula remains constant all the time. It never changes. The times 180 remains constant, okay? It never changes. The only thing that changes is the 3, or the n, which is the number of sides. And all of that just depends on the shape that you're trying to find the sum of the angles for. Okay? So if you turn the page, you're going to want to get that study tip on the top of page 394 in your notes. And I'll put it up on the wall, or you can start copying it down. Because on your quiz, on your study guide, in your assignment, you will have shapes referred to by the name of the polygon. And you already know a lot of those, but some of them you may not be as familiar with. So we're going to do this little table that starts with number of sides. And then the name. And I'm not going to use the number of sides 3 because we all know that's a triangle. So a shape that has 4 sides is called a quadrilateral. And if you already know what the name is of a shape with 5 sides, you don't need to write it in your table. A shape with 5 sides is a pentagon. And 6 sides is a hexagon. Seven sides, heptagon. And 8 sides is an octagon. Nine sides, nonagon. And 10 sides is a decagon. Eleven sides, hendecagon. And 12 sides, dodecagon. Now, those are the names that you have to remember on your own. Anything over 12 sides, we're going to use the variable n. Anything over 12 sides is what we call an n-gon. What I mean by that is if a shape has 13 sides, we call it a 13-gon. And if a shape has 19 sides, what do you think we call that? A 19-gon could. You get the idea, right? If the shape's got 37 sides, it's a 37-gon. Okay? So, couple types of problems that you're going to see in your practice today. One type of problem, you'll be asked to find the sum of the measures. And let's say you're asked to find the sum of the interior angles for each polygon. And let's say you're given a hexagon. What you do is you determine the number of sides that the polygon has. Hexagon has 6 sides, so we take 6 minus 2 and multiply it by 180. So the sum of the angles of a hexagon is 4 times 180, which is 720. Decagon? All right, you can look at your table, or does anybody remember how many sides a decagon has? 10, so we take 10 minus 2 and multiply it by 180. So 8 times 180. 1,440. All right, that's the sum of all of the interior angles of each of these shapes. Now, polygons have the same number of interior angles as they do sides. We'll talk about that more on Monday, but I just wanted you to have it in your notes. That polygons have the same number of interior angles as they do sides. So a hexagon has 6 sides, and it also has 6 interior angles. A decagon has 10 sides. It also has 10 interior angles. So if you were asked to find an interior angle measure or one interior angle measure of a decagon, you could take 1440 and divide it by 10, and that would give you one of the angle measures. It would have to be a regular decagon, though, because remember, in a regular polygon, all the sides are the same and all the angles are the same. But moving on from there, some of the other questions you're going to be asked today are to find the measure of each interior angle. So on page 394, we've got a polygon down there, and we got to find the measure of each interior angle. All right, so we've got this shape right here. And our vertices, let's go with A, B, C, D, and E. And then each angle has an expression. So angle A is 2x degrees. Angle B is 142 degrees. Angle C is also 2x degrees. Angle D is 3x plus 14. And angle E is also 3x plus 14. So if we have to find each interior angle, the first thing that we have to do is solve for x, okay? And in order to solve for x, we have to write an equation. So we're going to take all these interior angles, and we're going to combine like terms. So we're going to take a 3x plus a 3x, which is 6x, plus 2x, plus another 2x. So we got 6x plus 4x gives us 10x. We've got 10 x's here. And then we have a 14 plus a 14 plus 142. So 14 plus 14 plus 142 is equal to 170. So we got 10 x's plus 170, and all of those angles, the 142, the 14, 14, these 5 angles, what do they need to sum? Careful now. This shape has 5 sides, doesn't it? So the sum of the angles of a 5-sided shape, that's a pentagon. So if we go down here and we do 5 minus 2 times 180, what is that? 3 times 180, which is 540. This shape has 5 sides, so we have to use our interior angle sum formula to determine what to set this equation equal to. So we take 5 minus 2 times 180, that's 540. So this 10x plus 170 has to equal 540. Now we've got our equation set, we can solve for x. All right, so if we subtract 170 from each side, then we got a 10x that's equal to 370. Divide both sides by 10, and our x is equal to 37. So we're one step closer to finding each of these angle measures. So, angle A, yes? Sure. No, just go. Angle A is going to be equal to 2 times 37. And 2 times 37 is? Correct, 74. And going around, I'm going clockwise around this shape. We already know angle B, 142. Angle C was the same as angle A, so it's 74 degrees. Angle D, all right, we got 3 times 37 plus 14. And 3 times 37 is 111 plus 14 is 125. And angle E is the same as angle D. They both have the same expression, so angle E is also 125 degrees. Everybody okay with that? All right. What's the key? What's kind of the key to finding the measure of each interior angle? What do you think the key point is in all of this? Do you think it might be making sure that you're setting your equation equal to the proper sum? Real important, right? You can't just use the same number every time. You have to find out how many sides the shape has. You have to insert that into the formula to find the sum of those interior angles. That sum is what you set your equation to when you write your equation. All right, let's look at one more shape. And we're going to write the equation, and then I'm going to let you finish it on your own. If you've got this shape right here, and let's say we've got angles A, B, C, and D again. And maybe angle A is 5x plus 10. And angle B is 10x. And let's look at angle C and angle D. They both have just a symbol in there. So what's the measure of angle C? 90 degrees. That's what that symbol means. What's the measure of angle D? It's 90 as well. So when we combine our like terms here, we've got a 10x and a 5x. So that's 15x. And then we have 10 plus 90 plus 90. Well, 10 plus 90 plus 90 would be 190. So our 15x plus 190 has to equal, now we've got to do our n, which is 4 sides minus 2 times 180. We have to find out what the sum of these interior angles should be. And we have to use this formula, n minus 2 times 180. So 4 times 2 is 2 times 180 is 360. So in this case, the sum of our interior angles is 360. Okay? That's our formula. We subtract 190 from each side, divide by 15. That gives us our x. From there, we can substitute the x times 10, substitute the x times 5 plus 10 to get angles A and B. All right? So super key point right there. You've got to use this n minus 2 times 180 to determine what to set your equation equal to when you combine all your angles. All right? Anybody have any questions? All right, then on page 398 today, I want you to do problems 12 through 19.